Hey there, welcome to dotnetFlix. So on the previous episode we talked about NATS, which is an open source high performance messaging system. And in this episode we will look a little bit further into it.
Yep.
So you've already shown some demos with some basic pops up.
Yep.
You've really shown how lightweight the protocol is. You
Yep.
can even just create a TCP connection using Telnet and communicate with it,
Yep.
which is very cool. And now we want to look at some more advanced stuff.
Yep.
Clustering, you mentioned last time.
Yeah, and that's streaming.
And that's streaming.
Yep.
Okay, so let's dive in.
Yeah, so like I said, if you look at the last episode, NATS is really lightweight. It's just a server that you put up and then it starts listening for messages. But I also told you that it was really highly available and robust and stuff like that. Well, to make that happen, of course, you need some kind of clustering, because if you just have one server that does all your messaging for all your distributed systems components,
may not be very highly available.
yeah, that's a single point of failure.
Yeah.
So that is why NATS clustering exists. And I will show you a little bit how that works and also how they really intelligently build that into NATS while keeping it really straightforward and simple. So you can cluster multiple NATS instances on the same machine or on different machines if they can reach each other over a network. And then you can basically create a mesh of NATS servers.
Cool.
And you do that by specifying you specify different other servers that are running.
Yeah.
So if you have a server up and running and you start a second one, then each server has a special endpoint that you can start, that it starts listening on, that can receive clustering requests.
Okay.
So when you start then the second server, you have to specify this endpoint, which is just a URL and a port number.
Yeah.
And then if it can reach that server, it will start communicating with each other and build a mesh of two servers.
Okay.
And then you can add a third one or a fourth one.
And so the only requirement is that they can reach each other over a network.
Exactly.
So if I want to deploy this in the cloud, let's say to Azure,
Yeah.
I could deploy it across geographies in different data centers.
Exactly, yeah.
Cool.
And also if you look at container technologies, Kubernetes, stuff like that, you could, for instance, say, okay, I will just spin up a cluster, and then if the machines can reach each other, you have a highly available cluster of NATS servers. The cool thing is that if you're a client, you just have to connect to one of these servers, and then you will be able to call into that server, and then messages will be distributed between the servers in this cluster automatically.
So you can connect to the server that's most closest to you.
For instance, yeah.
And then a subscriber connecting to the other side of the world can use that server. And
Exactly.
Yeah. All just works.
That's how it works. And you can also specify multiple of these services when you connect. That's one of these options that you can specify. And then if you are disconnected, it will automatically try to connect to another one of the services. Yeah. But it goes even further than that. So if you add servers to the cluster, this will automatically be communicated to all the other servers. So this mesh is built up automatically, but it is also communicated to the clients. So you will be updated so you know that there are new servers in the cluster,
comes along.
which is pretty cool. And so changes in the topology are automatically distributed. And this is very powerful because what you could do now, for instance, this is this two server setup that I was talking about.
Yeah.
And I have a client connected to server A and I have a client connected to server B. And client is in this case the NATS client. Both could be a producer or a consumer, but they are using NATS. So I have these two instances. If I then add a third instance and I point it to one of the two other instances, then the mesh will be created and it will start working in this cluster. And then new clients can just connect to this server and then communicate to all the other clients out there, which is already pretty cool. I showed you this elaborate heartbeat mechanism with ping pong. Well, basically, if this server dies, then its heartbeat will stop, and other servers will pick this up.
Okay.
And what then happens is if this server dies off, it will automatically be removed from the topology.
Yeah.
This will automatically be sent to all the other servers and the clients. And then a client can be configured to just try to reconnect to another server in the cluster.
Right.
And then it can just reconnect to this one.
Nice.
And I've done some tests with this with a continuous stream of messages. And then if I connect this client that was connected to server B, if I stop server B, it will wait for a couple of seconds and then it will start getting messages.
Nice.
So there is some outage there.
Yeah.
You will miss some messages while you were disconnected.
Yeah.
And this behavior can be completely configured. So how long you want to wait, how much retries you want to do, all that kind of stuff you can configure when creating the subscription.
Right. So can you add some metadata to a server? So for example, if let's say server C comes up, can I add some metadata to that? For example, it's in the US geography. So that a client who gets a message, say this new server, can decide, do I want to connect to the US or to a Europe?
I don't know if you can add your own metadata, but you get some information when you connect to the server.
Okay.
I don't know what information what information is in there exactly, so I have to look that up.
Yeah.
But you do know what server you connect to. So the IP address and I guess the host name of the server or something like that.
Okay.
So you could deduce something from that information. I don't know if you can
you
add
can
tags.
uniquely identify it.
You can uniquely identify it, of course, by name and by host name. But I don't know if you can add tags or any metadata yourself.
Okay.
So this is clustering. I won't do any demo of this, but I hope you understand that this worked great. And if you have a cluster of NATS servers up and running, then you must have a pretty big disaster for everything to fall apart.
Yeah.
But
as long as you don't run them all on the same machine.
Exactly.
Right?
Yeah. So you really have to scale this out, and maybe even over, like you said, different geographic regions, whatever. So this is really nice for cloud scenarios.
Yeah.
And then there's NATS streaming, and everything that I've told you before is about NATS. And if you watch the first episode, I told you that is at most once message delivery. It's really simple. With NATS streaming, you will get at least once, and I will show you how that works.
Okay.
Well, NATS streaming is built on top of NATS, which is pretty cool. So first, when I started reading about it, I thought, oh, okay, how must I place this in my head? So I have a picture in a moment to show you how this works. And if you look at the documentation, then NATS streaming is often referred to as STAN. So it's NATS the other way around. So I've just put it in this slide to make sure that you don't get confused if you read that. And it's also open source.
Yeah.
It's just as NATS. You can just find it on GitHub and you can see the code.
And so is it an entirely different process? Do I run it separately?
Yeah,
from NATS?
you run it separately, but this is the picture that I was talking about. If you start the NATS streaming server, it's just a separate process. It is basically a NATS server that will do the communication from the clients, but the streaming module that is also started when you start NATS streaming will just connect to the NATS server as a client, as a consumer.
Okay.
And it will consume all the messages and then send it to some storage mechanism. And this is why you get at least once delivery. So if you're offline as a client and messages are sent, they're stored in the storage. Yeah. And then once you connect and you say, give me the messages, they will be sent to you.
Okay.
This storage is completely pluggable. So by default you have in memory, but you can do file system, you can do a couple of databases. And of course it's open source, so you can write your own providers for storing the messages.
Nice.
And then if you look at the application code side, when you use the NATS streaming client API, it just encapsulates the NATS API and it adds some stuff.
Cool.
So like I said, messages are stored in a message log, and therefore messages are basically sent to a channel. That is a subject, as we know it from vanilla NATS. But in the documentation, you talk about a channel.
Okay.
And the really cool thing about it is that messages are not destroyed in this channel. So messages will stay in the channel for a certain amount of time. So they're not removed once they're delivered to the customer.
So you can also, just like Kafka, for example, you can play
exactly,
back.
Yeah, and there are some quotas that you can configure. So if you have a message log and it is filled up, so it is, you cannot put any more messages in it, then it will start to remove messages at the beginning of the channel, and then override stuff.
Yeah.
So you have to be considerate of that. But basically, messages will just stay in the queue. This will, like I said, at least once messaging semantics versus at most once for NATS. And you get persistence, but also acknowledgements. So it's not just persisting. You will get an acknowledgement from the server that the message was sent and stored in the streaming server. And you can do that automatically, or you can also do manual acknowledgements of the message once you have received it.
Okay.
Just as in, for instance, RabbitMQ, you can also do the same thing.
Yeah.
So as you can see, this just adds a couple of these capabilities to NATS if you need them. Like you said before, just as Kafka, for instance, is used a lot, you can replay the messages in the queue, and you can also specify the starting point. And I will give you, I will show that in a minute in the demo, that there are several ways of replaying stuff. when you subscribe to this channel for receiving messages, there are basically three kinds. You have a regular one and a queue group one.
Yeah.
And the queue group is for what I showed in the first episode for load balancing.
Yeah.
But there's also a durable one. And this is pretty important because if you have a regular subscription, then you as a consumer are responsible for remembering where you are in the message queue.
Okay.
But if you make a durable one, you can specify a unique client ID, and then the server will remember that for you.
Okay.
So then you don't have to do anything, you just connect.
Automatic checkpointing versus manual checkpointing.
Exactly, yeah. And wildcard subscriptions are not supported in this scenario.
Okay.
So that's... Okay, so let me show you some code, how you can use Stan in this case.
Stan.
Just as with NATS, there's a connection factory available.
Yeah.
And in this case, it's the Stan connection factory. You can specify some options to influence the behavior of the server. And then, in this case, I'm just in a loop. I will send a couple of messages to the server. And then I create the connection. If you start NATS streaming up, it will create a test cluster.
Okay.
You can specify this name, but I haven't done that. I tell it my unique client ID, and I pass in the options.
Yeah.
And then in a loop, I will be sending messages, and this is pretty similar to what I did with NATS. You just publish a message to a subject, nats.streaming.demo.
Yeah.
The only difference here is that this subject is now a channel, and it will be stored on the server.
Okay.
So if I, for instance, now start the producer, so So I have NATS running on my machine, I have NATS streaming.
Yeah.
So this is NATS streaming that I just started up on my machine, is just one executable. And here you can also see I'm listening to 4223.
Yeah.
And I can also see that
I'm using the memory store.
That I'm using the memory store, and these are these quotas that I was talking about. So there are some limits on how many messages, how many subscriptions, and you can specify these on the command line or with a configuration
that's also
file.
dependent on the store.
Exactly, yeah. So if I now go to the producer, this is the producer one.
And you don't have any consumers running?
No, there are no consumers running right now.
Yeah.
So I run this, and then it will connect to the server and send these messages.
Okay.
And they will be stored. And if I now go look at NATS streaming, you also see that a channel was created, nats.streaming.demo. So you see that this works. I am now going to the consumer. I have a separate window for that. So this is the consumer side. And then first look at the code. Well, it's pretty similar. You have a connection factory and you create a connection. That's it. And then it's pretty cool because with these options that you can specify, I do standard subscription options.getDefault options, I can specify what I want. And if I don't specify anything and then subscribe to the nats.streaming.demo subject, nothing will happen because it will just start at the end of the queue. It will just say, oh,
okay, so it will only receive any new messages.
It will only receive any new messages. So if I start this, it will just start and it will say, okay, I'm done. There are no messages that I need to handle. Oh, I have to specify a client ID, client 01, whatever. And it started.
Yeah.
So the cool thing is that I could say, for instance, well, when I start, I just want all the messages in the queue. So if I now start it again, then you will see that once it's started, it will get all the messages 100%.
Yeah, nice.
This is awesome. And then it starts waiting. And if I now send more messages, they will automatically come in. If I now go back to the producer and I send another 25 messages, and I go back and I restart the consumer, then you will already see that it will get 2 sets of 25 messages.
Yeah.
So the first batch and the second one, which is pretty cool. But what you can also do, for instance, is say every message that you send will get a unique
ID.
Number, an ID. It's just an increment.
Just a sequence number.
Just a sequence number. And if I say start at 15 and I pass that in as an option and I start the client or the consumer, then it will just get all the messages from 15 onwards.
Yeah.
Right?
Yeah.
So that's pretty cool stuff.
But I guess those numbers could be reused when you
so,
set a maximum age and stuff like that.
Yeah, so you have to be aware of that. Yeah. Well, and then there are some other options. I won't go into them all in detail, but you can imagine what happens. You can say, give me all the messages sent since half an hour ago.
Yeah.
Or since really 10 minutes ago, or since a certain date. Or start with the last received, which is also pretty neat. If you say, okay, I don't want all the messages, but I want to catch up and I want to know what was the last one. Yeah. And then from that one on, I want to keep up.
Yeah.
Right? So that.
But I guess that would require a durable subscription?
No, you just get the last message in the queue. And then from then on it stops.
Oh, the last available in the queue. Yeah, so right. Not the last one I have previously.
No, it's just the last one. So it's just the last message 25 that was sent for the second time.
Yeah, and it's number 50. Yeah,
it's number 50. And then from now on, I can listen to messages. Yeah. So you can see there.
That's nice.
Yeah, there's a couple of cool things. And then if I do this one, if I specify a durable name, then the server will keep track of where I am.
Yeah. So if your process crashes at let's say after message 40, and it starts up again, then the next message you will get is 41.
Yeah. And this is pretty cool because if you crash, you have no way of knowing where you were. If you don't store that somewhere else in a database or whatever, if you store it in memory, then it's gone. So this is a pretty cool option. Yeah. So that's net streaming. That is what I wanted to show. Cool. And then there's the last thing that I want to show you, because now I've shown you NATS and I've shown you net streaming. They both have very different characteristics. And I was thinking about a demo application, and this is just a microservices-based application for a bookstore. It's just a fictional thing. This is not a production thing. And what I did was create an event-driven application, and I used the CQRS pattern. So I separated handling commands and handling queries. And this is what this application looks like. So I have a store app, which is just a web application. I have an order processing service. This will receive, create an order, order a book, all those kinds of commands. It will store these orders in a database, and it will then send an event to the orders query service that an order was created, or a book was ordered. And then from this order query service, I can get the information. So I get my my order and what I ordered and what the costs are, all that kinds of stuff. Yeah. So I wanted to build this completely event-driven, so there are no APIs. It all goes through NATS or net streaming. Okay. So first of all, I've added NATS to this solution, and all my commands will be sent to NATS, and my order processing service is a consumer. Yeah. And the cool thing about this is that if my order processing service is offline, I will send the message from the store app to the order processing service. I am using the request response here, so I'm waiting for a response with a timeout. Yeah. And if a timeout occurs, I can just say to the customer, sorry, the service is offline. Yeah. So this is fine to do it over NATS. Yeah. The same goes for queries, sorry for that.
And that request response pattern we've looked at in the first episode.
Yeah, yeah, totally. The same goes for the query. So I just send the query, I tell it what to get, maybe one order or all the orders, and then I send the order data back and I show it in the store app. So this is pretty simple. Yeah. And same goes here. If a message is not delivered to the orders query service, I get a timeout and I can retry or say, sorry, this service is offline. Yeah. So that's fine. So for this, I can use the NATS characteristics of at most once delivery. Yeah. But, like I said, in a CQRS pattern, you must be aware that the order processing service and the query service must stay consistent, because else, if you get a query, it might say something completely different than the order processing service has. Yeah, yeah.
So you need some guaranteed delivery there.
You need some guaranteed delivery. So, and that's the cool thing. Now I could use net streaming in the same solution, and then once the order processing service has handled a command, it will send the event to net streaming. And even when the orders query service might be offline at that moment, once it comes back up, it will get the messages from net streaming because it's persistent, and it will update the query model. Yeah. And the nice thing is that if you now, for instance, say, I need a separate shipping service, I could even add that. And then make that a consumer of the net streaming server, and I could get the entire history. Yeah. And then start shipping all the products.
So even if you're putting that service in production at a later moment, you can just replay all the events and you've got some seed data to work with. Yeah.
So this is one example, but this is really cool that you can use NATS as well as net streaming in a single solution, because you just have different messaging requirements.
Yeah, different trade-offs.
Yes. So to wrap this up, this is a wrap up of both episode 1 and episode 2.
Yeah.
It is a performant messaging infrastructure. It is really cool if you build some cloud native distributed systems. It is simple, lightweight, resilient, as we saw with clustering, but you have to make sure that you know the requirements of your messaging. So do you want at most versus at least once delivery, and do you want raw performance or need raw performance, or do you want message persistence? Yeah. Because NATS streaming obviously is a lot slower than NATS.
Yeah, and I guess that also depends on what kind of messaging store you put in there.
Yeah, totally. So make sure you understand and accept these trade-offs, and make sure that you know what the implications are, because it is simplicity and it is performance, but it is a trade-off. Use clustering to make sure that that is resilient enough, and then check out the documentation and start experimenting. It is pretty well documented. If you go to nats.io, which is the starting point for this, you can click through the documentation. There are some samples, there are some tutorials in there.
Cool.
And so that's it. Start experimenting.
Yeah, it really looks very easy to get into to get started with. And you've got the NATS.io website here. You've also got some demo code from these 2 episodes
of the demo
GitHub repository. Yeah. So we will definitely put that in the links. And then I just hope you have some fun playing with NATS. So thank you very much, Edwin.
No problem.
And see you next time at dotnetFlix. Bye-bye.
Later.